Hello everyone. Today we're going to work on IXL assignment K7V, multiply and divide positive and negative decimals. When we're working with positive and negative decimals, that is technically called a rational number, because rational numbers include our decimals, our fractions, and our integers. So when you're working specifically in this case with positive and negative decimals, with that form of a rational number, if the two numbers, if your two decimals have the same sign, then your answer will be positive. If they have different signs, then your answer will be negative. All right, now let's quickly review the steps for multiplying decimals. When you multiply decimals, it's really similar to just standard multiplication. You don't have to line the decimal points up. In fact, it makes more work for you if you do. So you just kind of temporarily ignore the decimal points, set your numbers up, and perform your multiplication. Then when you're all done, you go back and look at your original problem so that way you can determine where that decimal point really needs to go. So if we look at our problem here, we can see that in our first number, we have two digits, so the 2 and the 4, that follow our decimal point. In our second number, there's only one digit after the decimal point. So we're going to add that up. 2 plus 1 gives us 3. So that means in our final answer, we need three numbers after our three digits after our decimal point. Another way of saying that is we need to move our decimal point up 3 times. So 1, 2, 3 lands us right here, and that is the proper placement for our decimal. All right, let's now review how to divide decimals. So if you are dividing a decimal number by a whole number, so say you would have, 15 and 5/10 divided by 5. Nothing really special. You just bring that decimal point up, perform your long division. However, if you have a problem like you see here, and you're dividing a number, whether it's a decimal or not, but if it's being divided by a decimal number, then we have to do one little step before we can perform the division. So you'd set up your division problem, but then you would need to move the decimal point, because our divisor, so the number we're dividing by, cannot be a decimal. We need to move that decimal point as many times as needed to turn it into a whole number or an integer. So in this case, we would need to move it one time to turn that 5 and 5/10 to a 55. Well, we can't just change one number without changing the other. That'd be creating a brand new problem. So we need to also move the decimal point of our dividend, the number that is being divided. So if this is moved once, it would also be moved once here, creating the problem of 137 and 5/10 divided by 55. Once you've done that, you just bring that decimal point straight on up and then perform your long division per usual. So really, hopefully what you've gathered from this is that where your decimal point goes is, the main difference, but the actual process of multiplication and division is something that you've been doing for a while now. And it's pretty, similar. So let's go ahead and switch on over to IXL so we can do some practice and see all of this in action. All right, here we are on IXL. Remember, the assignment is K7V, multiply and divide positive and negative decimals. And don't forget that IXL also has a wonderful help video there. So if you'd like to see some more examples or just hear it from a different perspective, a different voice, please check out their video because it is really good as well. All right. So if we look at our problem here, we are being asked to multiply 5 and 5/10 and 0 and 2/10. So our first step is we are going to set up our multiplication problem. Whenever you're multiplying with decimals, the number that has more digits, so the longer number, is what needs to go first. In this case, it doesn't matter because they both have 2 digits, 5 and 5, 0 and 2. So I'll just go ahead and put the first one on top. And remember, when you're multiplying with decimals, you don't have to line up the decimal point. If they happen to line up, that's fun, but it's not a requirement. All right, so let's go ahead and multiply everything by 2 first. 2 times 5 is 10. Bring down the 0, carry the 1. 2 times 5 is 10, plus 1 is 11. Now we need to move over and multiply everything by that 0. But before we do, because we're moving over a place value, we need to put a 0 here as a placeholder. And now we can multiply everything by this 0. 0 times 5 is 0. 0 times 5 is 0. Now that our multiplication is complete, add up our total here. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. Now we're not quite finished because we need to determine where our decimal point is going to go. So remember, to do that, we go back and we look at our original problem, and we need to see how many digits fall after our decimal point. So we have 1 digit after our decimal here. We have 1 digit after our decimal here, meaning we need 2 digits that follow our decimal point. We need to move that decimal point 2 places. So 1, 2. So we have 2 digits that follow our decimal point. It is acceptable to leave your answer like this, but remember, once you've completely finished, if you notice that there are trailing zeros, you wouldn't have to keep those in your answer. So another acceptable form would simply just be 1 and 1/10. All right, now we have a problem here with a negative sign. So I didn't even think about this in the last problem because both of our numbers were positive. But do make sure that because we're dealing with signed decimals, so they could be positive or negative, to always watch out for that. So in this case, we see that one number is negative and one is positive. So I'm going to go ahead and figure out what the sign is going to be for my answer. Because the numbers have different signs, that means our product, our answer, will be a negative number. So I'm going to jot that down so I don't forget, but it's always good to also double check at the very end, because you would hate to do all the right work, but then forget that negative and type it wrong into IXL. So now that we've discovered that we know our answer needs to be negative, as long as you don't forget about them, you can just do your multiplication like normal. So I'm not even really going to write it when I do my problem here if I don't want to. If it confuses you, you can just write it like this. But if you're afraid that you would forget it, then you can put it there as a reminder. Doesn't really matter. All right, after you've done that, you will perform your multiplication. So we would have 3 and 5/10 times 2 and 6/10, giving you a total of 910 after you perform the multiplication and addition. But of course, as we know, we need to figure out where that decimal point goes. In our first problem, we have 1 digit that follows our decimal point. In the second number, we have 1 digit that follows the decimal point. So if we add that up, that means we need to move that decimal point 2 times. We need 2 digits to follow our decimal point, leaving us right here with 9 and 10 hundredths. I do remember that I have a decimal sign. Sorry, not a decimal sign, a negative sign. So we're going to place that there. And of course, we don't need the trailing zeros. So your final answer in the most simplified form would be -9 and 1/10. All right, next up is a division problem. So one of the most important facts about the division problem is honestly setting it up properly. Because if we set it up wrong, if we mix up our divisor and our dividend, then we're kind of messed up just straight from the get-go. So one thing that helps me is reading it. So we have -0 and 7/10 divided by 0 and 5/10. So that number that it's being divided by, well, is what we're dividing by. So it's our divisor. It's going to go on the outside. So we are dividing by 0 and 5/10. That's our divisor on the outside. And then our dividend is our negative 0 and 7/10. And just like before with the multiplication, when I see that there's a negative sign involved, I'm going to determine whether my answer will be positive or negative. In this case, because our signs are different, that means our quotient will be negative. So I'm going to put a little negative sign up here to help remind me of that. All right, now we are set to divide. Oh, wait, but are we? Yeah, we got to do one little thing first, because what we're dividing by cannot be a decimal. So in order to turn this into a whole number, I need to move that decimal point up one place. So my 5/10 becomes a 5. But whatever we do to one side or one number, we have to do to the other. We have to keep things equal. We have to keep it equivalent, meaning this decimal is also going to move and come up one place, giving us the brand new problem of -7 with a decimal point right here. And just like with the multiplication problem, if it confuses you to have that negative there, you can get rid of it. Oops. Just make sure that you don't forget to include it in your final answer, okay? All right, let's perform our division here. 5 can go into 7 one time, and 5 times 1 is 5. So when we perform that subtraction, 7 minus 5 is 2. When we're working with decimals, we don't have remainders. Decimals allow us to continue to divide until there are no more remainders, until we, have nothing left over. So when this happens, we just take our decimal point and bring it straight up, and we can add a 0 on the end, because we know that 7 is the same thing as 7 in 0/10. Or even 7 in 100/10. We can add as many zeros to the end, and it doesn't change its value. It just allows us to keep dividing. And then we'll bring that 0 down, giving us 20. 5 can go into 20 4 times. And this time it goes evenly with no remainder, meaning our division is done. And so our final answer is -1 and 4/10. Because we can't forget about the fact that we have a negative answer. All right, let's do one final problem together, and then you will be on your own. So for our problem here, we have 5 and 875 thousandths divided by -0 and 1/10. So I notice that once again, I have another problem where only one number is negative, meaning our answer will be negative. But just as a quick reminder, since we didn't see any of these, if both of your numbers are negative, if they have the same sign, your answer will be positive. But if only one is negative, your answer will be negative. So let's set up our division problem here. We have -0 and 1/10. I'm just going to write it. I'm going to kind of ignore the negative so I don't get confused. I will double check myself at the very end to make sure I haven't forgotten it in my answer. All right, remember that our number that we're dividing by cannot be a decimal. In this time, we need to move it just one place in order for it to no longer be a decimal number. That means for our dividend, the number on the inside, we also need to move that one place, giving us the problem of 1, then 58 and 75 hundredths. Before I even get started, I'm going to bring that decimal point straight on up. because now that it's been moved, it just stays there. All right, 1 can go into 58, well, 58 times, giving us 0. Well, bring down your 7. 1 can go into 7 times. Bring down our 5. 1 can go into 5 times. And we have a remainder of 0 and no more numbers left. So this one, you know, it was pretty easy to divide since we were just dividing by 1, but don't forget that negative. So our final answer would be negative 58 75 hundredths. All right, it's now your turn to practice. Of course, if you need help, please make sure to send me an email or come to a help session. Bye.